Alright, so before I get started, how many of you people are JavaScript programmers and you just really love it? There's a dearth of replies here.
Yeah.
Yes, to correspondence.
Okay. So, this is TypeScript. I titled it A Cure for Feeble JavaScript. For those of you who really do like JavaScript and you just don't want to say so, I thought that the title might make some of you a little bit unhappy or disgruntled. But in fact, it's kind of a misnomer because TypeScript is strictly development time. And it compiles down to pure JavaScript in the end. So in the end, you're actually still running JavaScript. And so for those of you who really like JavaScript, you're still going to get what you started with in the end. It's obviously here for the long term, JavaScript, and because it runs in the browsers, which TypeScript itself does not, it gets taken from the TypeScript down to the JavaScript. But it has some deficiencies. We have issues with global namespace issues. You can't use strong data typing. There's no ability for using classes and interfaces and object-oriented type techniques. So, can TypeScript be a benefit to you? Does it have any of its own issues? And what actually is TypeScript? So the first thing is that TypeScript is an open source project done by Microsoft, and they have a GitHub repository out there that you can go and look at. It gives you all the documentation. It allows you to contribute if you so choose. And it has links to whatever the current issues are that are bugs there, and there's a roadmap that tells you what future enhancements may be coming. TypeScript is a superset of JavaScript. So everything that you have in JavaScript is available in TypeScript. All it does is add additional features and functionality. In fact, if all you did was use JavaScript in a TypeScript file, that would be okay. Anything that's valid JavaScript is also valid TypeScript. I don't know why you would want to do that, but you could. I'm going to jump real quick. Over here to the TypeScript playground. What you see here is an example of straight JavaScript being used in a TypeScript file. So on the TypeScript side, everything written here is in JavaScript. And if you look over on the JavaScript side, what you see is the exact same thing with just blank lines removed. Okay, so this is, like I said, a sample of JavaScript in the TypeScript side, so it's basically the same thing. What you put in is what you get out. The fact is, if you took an application that had JavaScript files, and all you did was change the extension from .js to .ts, it would be perfectly legal TypeScript files. Of course, if all you did was change the extension, it wouldn't be of much value because what you put in is what you get out anyway. Let's go on to the next slide. Good. I'm on the wrong thing. A brief note about the TypeScript compiler. It doesn't actually really compile as the sense of what you would normally think of as a compiler. Like in C#, what it would take is the C# source code and convert it to like an assembly DLL file, a machine code. TypeScript is really a transpiler because it converts one source code to another source code. It's not a big thing, but it's important that you know it's not really compiling anything. JavaScript is not strongly typed. So what you could do in JavaScript, and it would be perfectly legal, is you could create a variable, assign it a value that's numeric, turn around and assign a string value to the same variable, or an object of some kind. And JavaScript wouldn't care. It would take it exactly how you sent it. But if you're expecting a certain data type and you have the wrong data type in it, JavaScript will not tell you that you have that error. It'll go along and compile and do whatever it needs to do and be just as happy. And you'll never know that there's a problem. On the other hand, TypeScript is strongly typed, and if you declare a variable and you give it a specific type like string and try to assign it anything else but a string value, it'll complain. It'll tell you that there's a problem, it'll highlight the error, and it gives you an in-your-face kind of indicator that helps you determine that there's a problem before you ever get to runtime and before you have testing that you wouldn't find in JavaScript otherwise.
Question.
Yes?
So it almost sounds like there's a contradiction there in, you said initially you could rename JS to .ts and use any JavaScript in a TypeScript file, but strong typing isn't available. If strong typing is only available in the TypeScript and you use JavaScript in a TypeScript file, wouldn't it violate some of the strong typing?
What it would be JavaScript with no strong typing. That's what I'm saying. You could actually convert, just rename the file, and it would run and be just as normal, but you would not get the benefits of using the TypeScript.
I guess what I was saying is if you intermix JavaScript with your TypeScript, it's going to interfere with the strong typing that TypeScript is going to try to do. Or not.
It depends.
The variables in the JavaScript weren't strongly typed to begin with, so it doesn't check for the type.
Right.
And even if you put them in the same file with TypeScript, if you don't bother to put the syntax with the type after the variable, it just lets you use it like JavaScript. It doesn't force you.
Okay.
It doesn't force you to do that. It just
Correct.
it just
If you want the
enforces it if you put it there.
If you want the checking, you do it.
Yeah.
Just write it.
What it actually does for TypeScript is it infers it as a type any, which means it's an unknown type. Strong typing allows for the static type checking, the member definition, all that stuff. This is something that you either love or you hate. Some people love the fact that in JavaScript you can be flexible and change the type as you go. I really don't like it. I prefer the strong typing because it helps me keep things straight. It's a preference, and like I said, you'll either love it or you'll hate it. So we're going to switch back to this JavaScript walkthrough for a minute. And if you hover over this greeter function, if you can see that, it's saying that when you call that function greeter, it's expecting a parameter of greeting, but it doesn't know the data type. That's why it shows up. So this is what you would see if you had something in a normal JavaScript type scenario. It just infers it as a type any. And TypeScript has, any just means that TypeScript has no idea. It's either going to be dynamic, changeable, or it's going to be something that it doesn't know. So if we went inside that greeter function, we typed greeting dot like we would with a normal dot notation. And as you can see up here, nothing happens. We don't know what greeting is. We don't know what data type it is, so it doesn't know what kind of operations are available on this data type. All right, so we're going to go ahead and change this and add some type annotation here. And we're going to say we want a string. Now, you'll notice immediately that this little new greeter at the line 12 has the highlighted red squiggly that says, hey, there's a problem. If we run this right now, there's a problem, but let me find my mouse somewhere. There it is. If we run this right now, it even tells us that we have an error. If we were to run this, and we click this say hello that you can barely see. I don't know if I can make that any larger. It pops up alert that says hello object. So with JavaScript, we wouldn't know what the problem was until runtime unless you're running some kind of testing, right? Now if we went ahead and changed this so that it's passing a valid string, our error goes away. If we hover over that greeter function again, now it tells us it's not looking for any data type. It's looking for a string. So this is helpful for us if we're trying to figure out what's a valid parameter, what we're passing, and what's available to be received. So now if we run it, it would turn out the right thing. It would say hello world. But now, if we type that greeting dot, if I can type, now we get a whole list of stuff that's available that's an operation on a string data type. So we can go down and pick the length or whatever, and as you look at this, you'll notice that it also tells you that length returns a numeric value. It returns a number. So we'll go ahead and get the length. And we're going to assign that to x. Now, because length returns a number, if you hover over x, x is a number. This is because TypeScript also infers a data type when it can, so you don't have to explicitly tell it what data type you're expecting if you have something that's already assigning it.
Is that
Okay,
only when you assign on declaration?
generally. That's the best time to use it. I wouldn't use it in any other place. I think you can do it in other instances, but like you could assign var x and then come down later and assign it to length, and it would infer that.
It would make X then.
It would then make x
enforce
numeric.
type.
Right. But at that point, you would not want to give it a type annotation in the beginning. So, but you could do that. So the strong typing for static type checking, like I said, that's like when you hover over the greeter function and it tells you what it expects. It goes out and looks for you and tells you what it needs. When you put it in the actual parameter and tell it what type it is, that's declaring your intent. And the IntelliSense for valid operations are only available when it knows the data type. So if it's an any or an unknown, it can't help you. But if you make it explicitly a specific data type, then it knows exactly what is available for that type. Any questions so far? So these are the basic types that you can find included in TypeScript. Most of these you already know. You know what a Boolean is, you know what a number is. In the case of TypeScript, it takes a floating point, just like JavaScript, for a number. You know what strings are, arrays are. It allows enums. Any is for unknown or dynamic data type. And it includes a type called void. And so far, I've only seen that as a return type for a function. I don't know where you would want to use that for anything else.
So it's not like an integer, just a generic number instead of decimal?
The number data type?
Yeah.
Yeah, it's just a floating point type.
You can't just say something's an int.
I'm sorry, I didn't
Like
hear.
just an integer, there is no...
If you don't assign it a decimal, it acts just like an int. But it is a floating point.
Well, and, I mean, there's like the hardcore assembly language in C where you've got an unsigned type of integer and different lengths of integers from
Right, it's
byte
not-
on up to.
It's not like that. It's not like shorts, longs, integers,
So-
U shorts, U longs, doubles, decimals. It's
Yeah.
all one data type.
It's
It's
just
all
like a
just a
double,
floating
yeah.
point. So, in that sense, it doesn't give you any extra functionality like the integers or the longs or the, you know, it's just a floating point.
I have a question on the difference between any and void.
Void means it has a total lack of data type. It has nothing as a value. It's like a null almost.
Any could be like a complex type of object.
It is only used, as far as I have seen, as a return type on a method, a function. So it returns void, yes. The any data type means I don't know what it is and I'll accept anything at all.
just like regular
Yeah.
JavaScript.
Yes.
Right, it's just like
Yeah.
regular JavaScript. So you can make it
I've only
a
used it to
number,
get
a
rid of
string, an
compiler
object.
errors. No, if I'm using an external library and I don't have a distinctly typed thing for it or something, and I want it to compile without errors, I'll throw that in there just so that.
Right.
Maybe for order.
That's really the only place I use that. You really shouldn't use it as a matter of practice, but if I can't determine, if I don't have the code to include, so I know exactly what the type is and it's giving me a warning about the type, I'll use that just to,
Right.
compile an error. Because you don't know what it is.
Okay, so TypeScript is also object-oriented. It has modules, classes, and interfaces, and even generics. So with JavaScript, most of the code that we write ends up in functions. It's just the basic unit for a JavaScript code. In TypeScript, you can continue doing that if you so choose, or you can use classes and interfaces. So like those of you who are familiar with C# or C++ or Java or anything that already includes those types of things, it's now available in JavaScript if you use something like TypeScript. Anything that you write in TypeScript that is the class-based approach will be converted to a JavaScript function for runtime.
Is it polymorph,
Meaning,
meaning that you can actually write two different constructors or, different types of call gates, and the language will use the appropriate one based on the types of the input arguments?
like inheritance?
Polymorphism is, if I write two constructors, especially in a strongly typed language, I can maybe pass
Like
it a
an
number
overrided-
or a string,
Yeah.
and it would use the correct constructor and do different behavior based on what type I passed it.
I have not seen it used that way.
Okay.
I do not know actually the answer to that. I know that it has one constructor, and that's the only methodology I've
Okay,
used
so
with it.
if it has only one, and its demands only one constructor,
I
then
don't know
it's
the answer.
likely not polymorphic.
Right, I just don't know the answer to that. I think that that's the
Yeah,
case.
so,
I think that
so
it only
there's one
takes
thing
one.
so there's one thing you can do, is you can implement multiple interfaces on a type, and
Yes,
then you can pass that object around and get your polymorphic behavior.
that is
right?
correct.
So you could have, the old print object, iPrintable and iCalculatable, kind of interfaces. And if you apply that to a type or to a class in TypeScript, you can pass an instance of that class
Sure,
around.
like making a getter setter type of thing, but with different argument types, and setting the internal.
Well,
Okay.
no, you're just passing around an instance that implements an interface. So whatever the interface does, as long as the concrete class, implements the interface properly, you'll get what you're looking for. And yes, I've done that before. I've done that in some projects.
You can have overridden functions. I think he's asking about the constructor specifically, though, for a class.
Or if you wanted to function with an optional parameter.
Yes, we'll get to that.
Okay.
Any questions so far, in addition to what's already been asked? Okay. So, let's talk a little bit about the modules. Modules are used kind of like a way of encapsulating certain bits of code and information. It takes the place of an IFE. You won't need to use an IFE if you are familiar with that, the immediately invoked function expression. It requires just that you use the word module, give it a name, and then you put it in curly braces. So what this does is it takes out the global namespace problem, because you're actually creating your own namespaces by using a module. There are internal modules versus external modules. Internal modules are what you create yourself inside of your application. External modules are things that you want to import in from outside. And they're used with Node.js and Require.js. If you want to know more about external modules, you can go to the TypeScript page and look at their handbook, and it will give you some information on that. I'm not going to get into that here because that's more of a larger picture. It's not really a basic thing. So this is a sample of what a module would look like. If you had a bunch of information that you wanted to be core to the module that's reusable across everything, you might make something like app.core as a namespace and put that inside of a module. What you'll notice is when it gets converted to the JavaScript side, it wraps it in two separate ifs and gives you two separate variables, app and core, that references those little spaces. And everything where it says use strict, anything else that you would want inside that module will be there as well, which is why we have the dot, dot, dot. Do we have any questions about what a module looks like or what it does? Okay. If you want to have an IFE and you don't want it to be within a namespace or in a module, the TypeScript version is very similar to the JavaScript version. All you do is remove the word function, tell it you're returning a void, and put in a fat arrow before the curly brace. And that will give you the normal JavaScript IFE if you so choose.
Why would you not use the module?
If you don't want to use something in a namespace, if you just want it in a regular way that JavaScript would use it, you could use just a regular IFE type.
That's one of the regular best practices for JavaScript is if you don't need something in the global namespace, you don't put it. So you wrap it up in an anonymous function unless you specifically need to put something on the global namespace.
An example where you wouldn't use a module TypeScript is if you're doing an Angular app, your app.js becomes app.ts, and you have to do it that way. You can't put a module name on it. It's going to be just straight app.js so that it picks it up and runs it the way it should. So you don't give it a module. That's just one example. Any of the JavaScript stuff that's expecting a certain naming convention for the startup, you can't put a module name in front of it because it will put, like she had the example, put the stuff in front of it. So it's like there, it would only know it as app.core in JavaScript, so and provide something for it.
It keeps it out of the global namespace, but it doesn't require that it have another namespace given to it. Okay, so an interface, one of the core pieces of TypeScript is that it does what you might normally term duck typing. It goes and it does type checking to see that the shape of an object follows a certain pattern. So an interface would be something that you would say, this is what I'm expecting for the class or the object that is implementing this interface. And it allows other code to say, this is what you're using, so this is what I can use. You can define properties and methods with their signatures and all the same things you would do for like a C# interface or any other interface that you're normally familiar with. So this is a sample of an interface. This is contained within a module. It defines one property, has 4 method signatures, and an object. Property is defined as a Boolean type, so that we know that it's a strong type. It has the 4 methods. Each of the parameters for that method are also strongly typed. And at the end you see where it says void. That's the data type that it is returning from that method. It could be a number, it could be a string, it could be anything if you're actually returning a value. In this case, log, the object, is an Angular object that references their ilog call. And we'll talk about this in a little bit. This is where a TypeScript definition will define for you what that is. If you notice the question mark next to the word data and title, data and title are parameters that are optional. So if all you did was pass in the message, that would be okay. If you just passed in message and data, that would be okay. In this case, data is defined as a type any because it could be different when it gets passed in, depending on what calls this. You'll notice the keyword export in front of the word interface. That's because this interface is contained in a module, and I want this interface to be something seen outside the module. And this is an actual interface that I'd actually use for my logging service. Any questions about interface at the moment? Okay. Then we'll get to the classes, which are just like what you would expect a class to be. It might be something that it's like a domain entity, a product, a sales order, something like that. Or it could be something that is used for services and factories that actually provide some functionality beyond just being a product or anything like that. Classes can be base class and derived classes. So you can have inheritance on these things. And for someone like me, this is more natural than putting everything in JavaScript functions. This is a sample of a really simple domain entity type class. Basically, you could use either one if you wanted. Like we said, a JavaScript is acceptable as TypeScript. The JavaScript function here has 5 parameters, arguments, and the TypeScript class has a constructor that also receives 5 arguments. Now I put public in there on the TypeScript class. By default, those parameters will be considered public. So I just put that in there so that you could see that you could put public or private or whatever you wanted to on this.
I'm sorry, what does public or private in that context denote?
Private or public allows the
Encapsulation.
Well, I understand encapsulation, but
it's like a property on the class. It either makes it publicly available or it makes it private and internal to the class.
okay, so I'm seeing that on a constructor's argument. I'm used to that being on a member function or a member variable.
It's a TypeScript shorthand.
This is
Okay,
shorthand.
TypeScript, so is it creating member variables from that constructor?
It is.
Okay.
You could actually
No,
have.
okay.
You could have actually defined those under the class.
Sure.
You could have had a private collar.
Okay, so
a private,
shorthand, it's
Right.
actually allowing me to, instead of the copy in like in a C++ where you have to copy into member variables,
Right.
it short circuits the copy.
By doing it in this way, instead of having this dot collar equal collar inside of the constructor, this declares the properties for you and assigns the value immediately.
Okay, because you have a problem putting that syntax of public or private
Yeah,
someplace.
seems
If you
funny
did-
putting it
Okay,
on the
yeah,
constructor.
it didn't compute, but all right, sorry.
It's okay. And there are some things, for example, that you might want to have a property in there that is not part of your constructor. And that would be something that would be in there
You
also.
put another variable and label it public or private.
Right. Let's go back to the TypeScript playground for a minute. So this is the same JavaScript that we looked at before. This is the same walkthrough that was in the JavaScript, but now it's been converted to use a class. So we have the greeting. This is the more normal syntax that you would see that you were asking about constructor versus declared variable. So we've got a greeting, and in the constructor it's passing a message, and that's getting assigned to the greeting. This is how sometimes you would use it if you don't want to use it as a constructor parameter type argument. My bad. The JavaScript, on the other hand, if you look over here, has been converted to functions, and it has a prototype for the method that's inside the class. Classes, as we indicated, also have inheritance. So this is a sample where you'd have an animal class and you'd have a snake and a horse. It's kind of silly, but it's how it is written. And all they're doing is instantiating a new snake and a new horse and telling it to move. So if you actually run this, it tells you that something is slithering, and Sammy the python moved 5 meters. And then something is galloping, and Tommy the palomino moved 45 meters. Well, we can extend that even further. No, I didn't need to add that, it did it for me. And we can add it another function. And we can say, let's see, this dot name.
Hey, Carolyn,
Yeah,
don't you normally put return types on all your methods?
I do. I'm just taking you through the
Yeah,
samples
yeah,
that are on
alright.
the playground.
Roger that. Yeah, that's Microsoft. They forgot to put the type.
That is
Forgot to put
Microsoft. That's right.
Yeah, crappy examples.
Okay.
Thanks.
So instead of doing a snake, we'll just say Python. And then we'll tell it that we want to do the squeeze move. Notice how the IntelliSense tells me I have a squeeze method available on here. So now when we run it, and I'm going to get rid of this horse for the moment. So now when we run it, all it does is the slithering, just like it did before. It says I've moved 5 meters. And now it says Sammy the python is squeezing you. So it goes multiple levels of inheritance is what I'm getting at. It doesn't have to have just one base and one derived class. It can go as deep as you need it to go. Some people don't like to take it too deep, but the availability is there. You'll also notice, if I put this back to its original sense, so what takes 24 lines over on the TypeScript side and is very clear and easy to read, it takes 40 lines over here and it's more convoluted. So classes, in my opinion, make things a little more easier to read and easier to follow.
Especially that top part right there.
The extends?
Yeah.
Yep,
If you're using JavaScript, you find another way to write that.
you probably would. Let's take that back down. So, before I get into functions, are we good with classes? Okay. So TypeScript functions can be either named functions or anonymous functions. It is best if you actually strongly type your functions if they're receiving any parameters or if they're returning anything. You need to let them know what kind of value is expected to be returned. You can have optional or default parameters. So for the sample up here on the screen, this build name function, if all I'm saying is I'm going to send in a first and a last name, and I have that question mark on the last name, that means it's optional. If instead I actually assign it a value, that means it's optional, but this is the default I'm going to use if you don't send me anything. It also has something called a rest parameter. It has to be the last parameter that you put in there, because what it does is it takes any number of options and makes it into an array and passes it in. So it could be nothing in that array, or it could be 500 items in that array. And it will take all those. For example, if in this example I have at the bottom, the rest of the name is an array that we're passing in. So if I put Mary as my first name, and then I pass in Grace, Christina, Pulse, Beverage, Nero, it's going to concatenate all that into the name and return that. It doesn't have to be a string. It could be numeric. It could be whatever.
So they all have to be the same type.
If you're passing in an array, it could be an array of any. So the famous this, the same trouble that you have in JavaScript with this is the same trouble you're going to have in TypeScript. Sometimes this means exactly what you expect it, and sometimes it means the window object because the context differs. So if you build a function and what you're getting back from the this keyword is not what you expect, then the cure for this problem is to use a lambda function. The most common reason you're going to find for this to occur is for callback functions, like if you're calling a web API and you're doing an async get or something like that, and it has a callback function, then what you get back is not necessarily the context you started with. So this is a real simple description of how this might work. In the top one, you'll see that the log error function is trying to assign message to this.msg. Well, if the context is wrong, it will say this is the window, and the window doesn't have an MSG property. So the way to get around this, if you look at the bottom sample, is you remove the word function in front of the parentheses and string and put a fat arrow at the end. And that will maintain your context. Don't ask me how it works. I just know that to fix the problem of the this, by using the lambda function, you can get it to have the proper context. This is the biggest problem that a lot of people will have, is trying to know when to use a lambda function versus a named function.
Are there any disadvantages to just using lambda anywhere?
Only if you really want this to be contextual. So for example, like I said, callback functions are the biggest problem. So if you have a callback and you want it to have access to properties inside that class, this is the kind of method you'll have to use as the lambda. TypeScript also has generics. In the second little bullet there, I have a sample of what a generic function might look like. This is exactly the same one as you would find on the TypeScript site. I just stole it because it was quick and easy. Basically what this is saying is I'm going to pass it in an argument of some kind of data type, and I'm going to pass the type back. So it's saying if I pass in, like on the bottom, I could pass in a string value, and what gets returned from that function is just string. If I pass in something that's a variable that has a numeric data type, it'll tell me numeric or number. Generics are really available for using classes and other things as well. This is something that you could take and run with if you choose. I just wanted to let you know that generics is something that is available in TypeScript. So what are some of the benefits that we've discovered out of this? We found that there's better type checking, which gives us instant error feedback so that we don't run into the problems where we find out that there's a problem at runtime when something doesn't happen the way we expected. Or we have a test that fails. We get immediate in-your-face response that there's a problem. We have code encapsulation via either the modules and the classes, which make it so that you're not using the global namespaces. Now, this mentions the refactoring. I'm going to jump back here real quick. Guess I should make that back to snake. So, if I highlight snake and I tell it I want to rename this symbol, I will get there. If I just change it from snake to snake 2, you'll notice it automatically changed my class name as well. It will go and find every reference to the object and update everything at once, so that you're not having to do a seek and find and replace kind of thing. It also has these peak definitions, which will take you to wherever the actual object is declared or first defined. These are the kinds of things that you'll have just because it's TypeScript. This will work in VS Code, it should work in WebStorm, Visual Studio, all that stuff. It should be able to use this. Close that peak definition here. And of course, our class-based object-oriented type techniques, which we love. Deployment time, the thing is that it gets converted down to pure JavaScript, which means that all browsers recognize it. And so far, I have not noticed any performance hit based on having used TypeScript as my origination before it gets converted into JavaScript. So, from what I hear, there really is very little, if any, performance hits. Are there problems with TypeScript? There can be. For those of you who are not familiar with it, if you're using it to convert something like an Angular app into TypeScript, it may take a little bit longer to code. It'll be cleaner, it'll look better, it'll be more understandable and readable, but especially up front when you're not familiar with how TypeScript should integrate, it's going to take you longer. Type definitions, there can be conflicts. For example, I'm going to pull one out of my hat. If you're working with Angular and you have a TypeScript definition file for it, and you have one for Angular mock, they may have some of the same definitions and they're going to have a conflict. What that may end up doing is giving you build errors. So you may have to choose, do I really need Angular mock? I'll just get rid of it, or I'll modify the TypeScript definition file so that there is no more conflict. There are times when there are no available definitions. So for example, we in LA have a few applications that use a third party called Bridget. There are no TypeScript definitions available for Bridget. So you either have to use an any or you have to make your own TypeScript definition. And we'll show you what a TypeScript definition is shortly. And possible naming collisions. If you name something app.core and you're bringing in a third-party module that also has an app.core, you might have an issue. And the module residue, if you remember looking up how simple it was, it just says module app.core in curly brackets, and then you've got two ifs basically converted into the JavaScript side with two variables. It can get a little verbose on the JavaScript side. But that's about it. There are two ways to install TypeScript, and it depends on what methodology you're going to use. TypeScript can be installed as a node package, which means you have to have node installed before you can do this. And then, like on the third bullet, you would just say npm install TypeScript globally. If you had TypeScript already on your computer or your machine, if you type tsc space -v, that would tell you what version you are currently running. If you have anything at all. And if you're running it through the node command line, you're going to want to install the TypeScript Definition Manager, which allows you to pull TypeScript definitions from the repository, which I'll show you about that in a minute too. If you're running Visual Studio 2013 or above, TypeScript is already included in the Visual Studio. What you're going to find is it's not going to be the latest version, so you're still going to want to download and install the more current version. You can get it from the TypeScript website. If you go to the home, if you get to the TypeScript now, you can see that there is TypeScript 1.6 for the different versions of Visual Studio. If you download this, it's just going to be a VSIX, Visual Studio Installer file. You just run it, and it will update what you have. Go ahead.
You only get the refactoring if you use either the Visual Studio or this playground. The command line won't help you rename variables, right?
That is correct.
Okay.
But if you're using an IDE like WebStorm or VS Code or Visual Studio, you'll get all that.
Oh, there's a plug-in for various IDEs for TypeScript?
You'll find when if you use Visual Studio that it already has some things that are, it has a tab in the properties that allows you to set some settings that help you run and build and do what you need to do for TypeScript. TypeScript definition files are important. What this does is allows you to run things like Knockout, Angular, Google Maps, Google Analytics, all that stuff, and still have strong data typing. It will define those things for you in the TypeScript definition file. The files for TypeScript definitions end with a .d.ts. They're all available, that are currently available, at a community-driven repository called DefinitelyTypes.
And a lot.
Yes, there are currently over 1,000. So, let's run out here real quick. This is DefinitelyTypes website. If you go to their repository, you'll notice that we had to truncate this to 1,000 files. There are still 289 entries that are not shown in this list. However, if you want to search this site for a specific thing, like Angular or Knockout, you can do that and it will filter this down for you. So like if you went up here and you search for Angular, well, that didn't do what I thought it was going to do.
That's just the answer.
I did this the other day. There was a search. I can't remember what I did, but there is a search feature in here somewhere. I'll have to find it.
I think if you go back to DefinitelyTypes.org, I think they have a search.
Yeah, up a little bit.
So if,
Yeah, right there, the repository.
Well, that's what I tried,
That
but it's searching the GitHub repository in this case.
link right there.
Yeah, but if
So-
you take the link back to the .org site, goes up.
Just
Yeah.
use
There.
your browser search with the Control F, and it
Maybe
will
it's-
search the page.
I thought there was a search on it.
I thought there was too, but in any case,
Have a directory.
well, that's not going to give you the repository. That's going to give you the same options that are above. But
That just takes you to it.
so if you didn't have a definition file, you can still use the library, you just won't get any of the benefits, will you?
you can. It might complain at you if you're telling it that you require the typings to be there.
Hey, Carolyn?
Yeah.
Yeah, okay, here's how you search it. You see the little hamburger menu to the right of DefinitelyTypes? It's right below 13. No, go back to where you were. Okay, right below where it says 1334 contributors, there's a little list icon. Click on
Okay.
that. Okay, click there.
There you go.
All right, then it says you can activate File Finder by pressing T, or see where it says definitely type, just start typing.
Okay.
Right where the cursor is, just start typing Angular, and it'll live filter and you can see.
Thank
so
you for looking at
search-
that.
Yeah,
Yeah,
I mean,
so,
that's one way.
right.
Yeah,
So you can kind of see what's out there. There's everything from the normal Angular to Angular Fire, just a whole bunch of stuff out here. And it's all related to the Angular JavaScript stuff. Going back to DefinitelyTypes, maybe. If you go up here to this TSD, this is where you could download the TypeScript Definition Manager for those who are using Node for running this. And this would allow you to pull down the definitions from there. In Visual Studio, if you manage your NuGet packages, and you can do this from the console portion as well, but if you come in here and you tell it you want knockout.typescript. Did I type that wrong? I can't see very much. I'm having a problem today.
Only searching the installed.
Oh, that's my problem. Thank you very much. So knockout.typescript.
you have an X in there, Carolyn. You misspelled script. There's an X.
Okay, I can barely see my own screen here, so.
Yeah, there you go. Yeah, just select that one in the list and you'll have it. TypeScript. There you go.
And the first thing that it shows up here is a TypeScript definition file. So you can install it right here inside of Visual Studio. And if you just type knockout, you could find it by searching whatever, it shows that way too. But just adding the .TypeScript will help you selectively define your result set. Did I have anything else? Oh, yes. Okay, so let's put that, let's close that. Hide that, hide that. And this is basically the last slide I'm going to show you. And if you want, I can show you some code and some things like that, but I just wanted to mention TSLint. It is for TypeScript what JSLint is for JavaScript. It's just a configuration file that tells you what you consider a valid operation. So like, if you say all your string values should be in single quotes and not double quotes, you can tell it that. And then it will, when you try to compile that code, it will pop up either warnings, messages, or errors. It says these things are not fitting in with what you have defined as our requirement. Visual Studio actually has a default TSLint configuration file. It's going to be somewhere in user whatever your name is, app code, and somewhere down in there in those directories. So it has a definition that will work for every project you use that has TypeScript in it. If you want to make everything the same, you can modify that and it will work across the board. If you want some differences, you'll have to have your own TypeScript file. So, I don't have mine open. This is a sample of a TSLint configuration file. So, it has all kinds of stuff in there. The one like I mentioned, if you want your quotes to be single quotes and not double quotes. If you want to allow the triple equals, true or false. If you want white space after or not have white space after your curly braces, etc. and so forth and so on. I think I don't have any. I had an error at one point, but I think I fixed it. So this right here, I don't know if I can make this any bigger. Nope. This is the properties for this project, and as you see, it has a TypeScript build tab in it. So you can tell it what kind of version of ECMAScript you want it to run for. ECMAScript 3 is for IE 8 and below. Pardon?
What?
ECMAScript 3 is for IE 8 and below. Yeah, something that doesn't really
Nobody
exist.
uses it.
That's right.
Except for some of our comments.
Right.
Yeah.
You're not likely ever going to use that. ECMAScript 5 is the current version that most browsers recognize, and ECMAScript 6 some browsers don't recognize yet, so it's safe to use ECMAScript 5 right now. I have it marked to compile. Go ahead.
Yeah, so this is actually one of the reasons I really like TypeScript. To some degree, it future-proofs your project. So you don't have, you're not sitting there with a bunch of JavaScript, because the TypeScript compiler will always be able to compile to a version of JavaScript, because we know that, if you have a long-term project, and there's all these changes, because we all know browsers are evil, because you've got your code in TypeScript, it'll be able to port to whatever version of JavaScript that's out there. So if you have an app that's going to live long term, like a 10-year app, which we make, that's one reason I love TypeScript, right? Because there's such a huge investment in TypeScript today at Google, Microsoft, all these guys, Angular, well, that's Google, right? There's such an investment in the real, out there in the wild, in TypeScript. This is one of the reasons that I really like it.
Did you all hear that?
That little checkbox. that little checkbox right there is the reason I really like it.
What Carl was saying is that one of the advantages to TypeScript is that it's kind of future-proofing what you're using for the browsers, because by using this ECMAScript stuff here, it allows you to get what you want for what's currently available, and then you can always upgrade it and do what you need to do for the ECMAScript later. And it just makes it, because it just converts it to JavaScript, so this will keep you with whatever current JavaScript is available.
Speaking about future-proofing, the data sig for TriNode showed me Modernizer, and I was wondering when you were describing the data types from DefinitelyTypes that had been converted, seems like you've got a choice of how you would encode that in TypeScript for the different interfaces.
Okay.
So, for the different libraries that you have on top of your JavaScript, right? So you have some choices to make, and now there's a documentation issue, because if you're used to using, library X, and it has a type of interface in JavaScript that, is of a certain flavor.
Right.
Whoever's written the data type.
If they're not keeping it up to date with
Well,
the current.
or they've just chosen a flavor of implementation in TypeScript for that interface, right?
Right. Well, if we look at, let me finish this and I'll show you some actual definition files. So in here you can tell it to compile on the save rather than doing the building of your project or solution. And it has this thing called a module system. So let me see for a second here. I don't know what the system or the UMD is, but the AMD is for compatibility with required.js, and the other one is for compatibility with Node.js or Browserify or the libmodule packager. I don't use any of those inside of this. This particular application is an Angular application with a Web API background, so I don't need any of that, because everything I need is right inside of my Angular application, and I'm not requiring any external modules or anything. This will tell you to compile the output if you want to a specific file, if you want to keep comments or not, if you want to put it in a different directory. And this last thing I really like is to generate the source maps. So what happens here is when you're running Visual Studio, if you have the source maps, you can actually debug the TypeScript files, not the JavaScript files, which makes it really cool. So when you get these definition files, if I can see, it adds a folder called typings under your scripts folder in this case. And under this you'll have all these various, in this case Angular stuff, Bootstrap stuff for me. And then this is one that I created because Bridget didn't have one. It's really simple. You just tell it what is available from the application that you expect, and what, in this case, methods. It's all I'm putting in there is methods, what their data types are, what they return. And that's how, when you actually utilize it inside of code, it can say, I understand what this means now, because I don't have to put any everywhere. This is the layout for TypeScript. It has an interface, and at the bottom it just declares the module with the variable and passes that variable back. It exports it out. If you want to see a more convoluted one, This is one from the actual repository, not one that was self-created. But it's got the same kind of information. It tells you namespaces, gives you an interface for all the stuff that is available, the route harms, the route service, the route itself, and it goes on and on and on. It's just a way for TypeScript to understand what is expected from this third party. Do we have any questions, or you want to see any code, or I'm not sure what time we're at.
So on your first TypeScript project, what was the hit on your productivity?
I haven't noticed any change as far as, I'm sorry.
It's like no
I'm thinking
learning curve.
performance. Productivity, it took me, because I was trying to familiarize myself with how to make it work with Angular, it took me probably twice as long initially. Now that I'm familiar with it and I have a basis for like a template for myself, I have no hit at all, nearly. So once you're familiar, it's pretty quick and easy. Is that what you were asking?
Yeah, so your developer ramp up time was pretty quick.
Yeah, especially for those of us who are already familiar with object-oriented type techniques. It won't take long at all to get TypeScript functionality in your head. The biggest question will be, you know, like Angular services or all the factories or the different variations that you might use with a third party. That's where the initial hit will come, because you have to figure out how they work together. So, as an example, let's see if I have one here. This is an Angular service. In this case, I'm making it as a factory. I've got another one that's used as a service. This was a sample project for me to get familiar with it. So I wanted to see the variations of using it with a factory versus a service. It's really simple. This is a class called Logger. It implements an interface. And the only real difference in some of this is I have a little piece that logs to the database on the server side if there's an error that's really crazy on the client side. But it just calls an instance. When you create the factory, you call logger.instance and it returns something of an iLogger type, which is the class of Logger. So it's really easy. It's just trying to get familiar with how the layout goes initially.
So have you brought in any third party like Angular like frameworks?
This is an Angular app right here, done in TypeScript.
Okay, so I'm using Angular material. It's like a,
Okay, so like,
I'd be afraid like bringing that in, it might take a little bit longer to get those features integrated into the Angular app.
only initially the first time you try it. Once you get familiar with how it works, it won't be nothing at all.
Well, you're refactoring a whole bunch of old JavaScript code, right? And putting TypeScript around it, or?
I'm taking Angular JavaScript and converting it to TypeScript
Okay.
for Angular.
So you really didn't have a whole lot of JavaScript in the project.
There is, in the case that I'm working on right now, I'm still converting a mobile application to the TypeScript. There wasn't a whole lot of plain JavaScript. There was some, but not a whole lot. The plain JavaScript.
Yeah,
Go ahead, Carl.
yeah, Carolyn. So I just recently finished the Sealed Air project, and it was my first like production Angular, or I used Ionic, but the same thing, it's still Angular.
Right.
And so I did the entire project in TypeScript, and it was the best decision I ever made. Period. It's not even. So the thing, it was really pretty complicated in what it did, a lot of processing, but it's almost like working in C#.
It is.
I mean, yeah. So the idea of, well, it's gonna take me a little longer up front, that's really just short-term thinking. It's not long-term thinking.
Right.
Yeah, right. Anyway, so if nobody heard that, then you can let them know.
Okay. Carl was saying that he just wrote an app that's done in Angular using the Ionic, and he said it was the best thing he ever did. The short-term thinking is, you know, what will it cost me up front? Well, the long-term thinking is, how will it improve it in the long run? And in the long run, the improvement is so vast as far as readability, usability, and being able to share with other developers.
This really answers the question of, for the non-JavaScript programming community,
Right.
why is everybody using JavaScript for everything now? And the answer is transpiling, because if you can make JavaScript look enough like an OO language,
It allows for
you
developers
can
that are
run,
familiar with that.
you can run everywhere the JavaScript runs, which is a lot of neat new places, and there's a lot of optimization. I was asking at a JavaScript presentation with a bunch of JavaScript people, why would you want to run JavaScript if you had all these other languages available to you? And the answer is that people have been optimizing the JavaScript interpreter in a bunch of different environments to make it run as fast as an interpretive language can possibly run. And that's giving you a large platform to run anywhere.
Right. And I'm going to just throw out this comment for those of you who might use Angular. The Angular team says that the best way to prepare for Angular 2 is TypeScript. So,
Yep.
Makes sense?
Isn't Google and Microsoft collaborating with TypeScript now?
They are. Well, Google chose TypeScript as the first level language for Angular 2.0.
right.
Instead of going with EMC6, they decided to go with TypeScript.
Does what Google's doing incorporate feature function of TypeScript in their, you know, what you're saying is Angular 2 going to be basically the TypeScript environment that Microsoft has?
They're building their
their own
framework, their code base using TypeScript
Right.
for 2.0. And I think they did that because they didn't want to have to choose which EMCA script they were going to target because of the browsers. So if they do this,
Yeah,
they can flip the switch like we showed there, and they
Right.
can produce.
I guess what I was trying to ask is, are they going to use the Microsoft tool set, or are they going to do their own TypeScript tool set along with Microsoft? They're okay.
Well, there is only one, even when you're in Visual Studio, there is still only one TypeScript compiler. Everybody's using the same one, whether you're in
That's
WebStorm, whether you're in Visual Studio, it's all the same tool, just
Okay.
the IDE's plugging into it and running it.
Well,
Right.
you know, the big guys don't have to play together, and there's been a whole bunch of lawsuits about that.
Google's putting in saying, if you guys build
Okay.
this out, we're gonna assume that you don't want to sit here and compete.
So they're playing nice.
Yeah.
That's great.
Well, and also TypeScript is, they call it a Microsoft technology because they started it, but it's open source.
Right.
If Google or somebody didn't like what they were doing, they can just take it and tweak it the way they want it, and
Boom,
fork
boom,
another
boom.
engine.
TypeScript.
Give it an integer
Google
type.
script.
Yeah.
Give it an integer type. All right, so are we good? We have any questions or anything that you want to see?
This was
I
excellent.
think
Thank
this
you.
is good. Very good. I'm done, Carl.
Okay, Carol.